Hello, everyone. I'm really sorry that I missed the final presentation. I miscalculated the time zone, and I really wanted to participate in the finals presentation because I prepared a lot. So I will. I'm going to record my presentation just in case you can have time to watch my recording and grade it for the final projects. So I hope it works. And let me get started. My name is Son Young Lee. I don't have any computer science backgrounds, but I learned so much preparing these projects, and I will try to present my findings as a non-computer science major. So the problem for this project is to build a recommender system by using the taste profile subset released by the Econest and to recommend the top 10 songs for user, which the user is likely to choose to listen. And my final solution I'd like to suggest for this problem is to sort the data by the most listened songs, let's say 1,000 songs or 5,000 songs, to make the data dense. And because we will use only a small subset of data, we'll have two types of users who have interacted with some of those songs already, which I categorize them as active users, and less active users and also new users who have not listened to any of those songs in the subset we chose. So for active users, we can recommend songs by using collaborative filtering technique, which finds a group of similar users who have listened similar songs and recommend songs based on that the song list by the similar users. Actually, there are two types of collaborative filtering, similarity or memory-based collaborative filtering and model-based filtering. I will use similarity collaborative filtering rather than a model-based collaborative filtering, which builds a model by using singular value decomposition, that is, by choosing the specific number of user features to make the data smaller but still representing the whole data set, and predict what the user might listen from the computed user features information. But I'm gonna use similarity based collaborative filtering by sorting the data by the most listened songs. And for the less active and new users, we can use rank-based recommendation, which is basically recommend the top most listened songs in the subset. I found a similar-based collaborative filtering technique the most effective in building a recommender system for this particular data set given for the project. The data is large, which contains 76 353 users and 10,000 songs, and has highly sparse user song interest metrics. So it means not many users have listened with many songs. 75% users have listened less than 30 songs. Moreover, 50% songs are played only once and 75% songs less than 3 times, which means we need to focus on songs listened by most users rather than songs most listened by certain users. Therefore, we can sort the data by the songs listened by most users and create a dense matrix to find a group of similar users who listen similar songs for better recommendations. So to find the most effective recommender system, I compare 3 types of techniques: clustering, similarity-based collaborative filtering, and model-based collaborative filtering. And I think the good recommender model should be able to offer personalized recommendations for active users, which reflect their past song choices or listening history faster and flexibly. So I found the similarity-based collaborative filtering offer most personalized recommendations with less computational complexity. So it means fast. It will be beneficial for music streaming service companies as well as customers who use streaming services if the service provides customized recommendations, and better if it can offer real-time based recommendations. So for active users who actively use services and listen and store lots of their favorite songs in the system, they'll be satisfied if their interaction produce more personalized recommendations. For less active and new users who are new to the service or have listened to few songs yet, they'll likely know what other listens and what popular songs are there in their own journey to find their own favorite songs. So successful music streaming services will accommodate the different types of users' needs in real time by building fast and flexible recommender systems. The hybrid use of similarity-based recommender and popularity-based recommender is the best fit to increase user song interactions and improve customer service. So in summary, for the highly sparse data set we have, we need to create dense metrics by focusing on the songs listened by most users. Play counts can be an indicator for some user preferences, but we can say with this data set, users dislike the specific songs because they listen only a few times. Because most of the users listen only a few times. Let's say some songs are listened by certain users more than 1,000 or 2,000 times, but they are rare cases, and these rare cases are not helpful in recommending songs for other users. So to build a better recommender system, to increase user song interactions with this highly sparse interaction metrics, we need to focus on the most listened songs and offer personalized recommendations for active users who already have interacted with many songs by using some similarity-based call-over filtering. And for less active and new users who have not listened to those popular songs, recommend the top most listened songs to increase their exposures to popular songs. And let me explain a little bit more about different techniques I tested with the dataset. With the clustering techniques, which makes user clusters based on their average play counts, I've got 11 clusters, but they were unevenly distributed due to the unevenly distributed dataset as explained before. The major cluster contained 93% users who have played less than 20 times, and some cluster contain only one user who played much more than the average. More importantly, clustering recommends songs with high average play counts, and the users in the same clusters get the same recommendations, excluding what they have already listened. Therefore, in my test, 93% users were recommended similar songs, and users' past histories are generalized by average play counts. So not much personalization, but it took short time to compute. On the other hand, similar-based and model-based call-over filtering techniques compute user similarities based on user song interaction history. Similarity-based call-over filtering performs better with dense metrics. There's a small subset because computing user similarity takes time, so it's better with a small data set and in terms of speed as well. But if the data becomes larger and more sparse, user similarity measured by cosine similarity I used for this model decreases, and the degree of personalization also decreases. However, model-based call-over filtering did not perform well with the small subset I made, especially when I chose only 50 user features to build a model to make it a little bit simple. But if I add more features or increase the size of subset, it will perform better. But the computational time also increase. And while building a new model by changing the number of features, I have to start again. So also it takes time. So in conclusion, the best recommenders I suggest with the current data set is using similarity-based call-over filtering based on recommendation can be the best model. It offers personalized recommendation. That is, if users have played different lists of songs from the most listened songs list, it computes similar score and select users who have high similar scores and recommend songs based on those small groups of people choices. So if users have more data input, more accurate personalized recommendation can be offered with the same model. Finally, I will sum up my presentation with key recommendations for implementing the similarity-based collaborative filtering recommender model. It is always important to check the distribution of user song interaction in terms of play counts. With the current data set, which shows highly skewed distribution, there's most users played a few times and most users listen only a few songs. It's better to find similar users using collaborative filtering rather than clustering users by their average play counts. But for collaborative filtering, we need to choose a subset of the data to create dense metrics, but downsizing the data means we may need to remove certain numbers of users with less interactions, that is, who have not listened songs in the subset. Therefore, it is important to determine how many most listened songs need to be selected for personalized recommendations, and how many less active users need to be selected for popularity-based recommendations. So we need to find optimal number. Finally, it is a good idea to start to set the similarity threshold for better personalized recommendations. For example, I use cosine similarity, which range from 0 to 1. And it will be good to group similar users with high similarity scores. But if we use score 1 or the score 1, which means the exact match or close to exact match, the recommendation may contain few diversities if a similar user listens to not many songs or not many artists. So it is good to set the adequate range of similarity threshold by trying different ranges. Thank you so much for listening to this presentation.